Hi, we're going to make a hyperbolic line perpendicular to another hyperbolic line from scratch using compass and straight edge. This is how it's going to end up. I know it looks at first like a lot of work, but it actually isn't too bad. And in fact, this segment was just done for illustration purposes. So there's actually one extra mark here. So you start with circle O, because that's your hyperbolic space. We're going to construct for ourselves a hyperbolic line. It can be any hyperbolic line that's not a diameter. Then we do its radical axis. I picked a point at random just to show you it works anywhere. And I'm going to construct the hyperbolic line through this point that's perpendicular to this hyperbolic line. As you can see, it's this little dude is what we're going to get. And it looks really good because if you look close, we've got a nice looking perpendicular there and here. You know, that's not a proof. Looks are never a proof. But the math says since the center is on the radical axis of this line has to be perpendicular to it. And because it goes through a point in its inverse, this has to be a hyperbolic line. So that's the reasoning behind it. We have to do all that much work to get this situation. So here we go, starting from scratch. I'll leave this up here, kind of like a ghost to remind us where we're going. So making a hyperbolic line with just a pencil means I want to get a right angle here, just tangent to that circle. I like to use these little the corner of the T-square where I put the inch marker, the transparent inch marker in position. So I'm going to try and get a nice looking T right there. And this is faster than, you know, doing the actual construction. Make sure it's long enough. These tangents have to intersect, so you gotta make sure your tangent's long enough. Same thing over here. I'm going to try and get a tangent going, so I put my pencil where it's supposed to be, get a perpendicular going. And now, if I did it right, that point of intersection should be the right spot for me to change the compass size to hit that point, that end point of a radius, and catch this other end point of a radius. And look, oh, it looks good. That is a hyperbolic line because it's orthogonal to circle O. I have a circle that's orthogonal to circle O. I built it using tangents. That's definitely a hyperbolic line. Now let's pick a point. How about right there? I'd like to construct a hyperbolic line that is perpendicular to this hyperbolic line at that point. So I picked that point at random just to show you that this isn't too tough to do. So first thing I do, there's two real quick ruler things to do. This is to get the inverse of this point. And this was on our last test. There's the inverse of that point. This point has its inverse right there. Wasn't that great? That was so easy. Now I also need the radical axis. So I'm going to put that in. And I can do that in blue. I mean, why not? May as well use other colors. So I've got a blue line coming through here, and that's a radical axis. Now, the center I'm looking for is going to be on this, because I'm looking for a hyperbolic line that's perpendicular to this given hyperbolic line. So the center I'm looking for is on here. If I can get one more thing to intersect it, I'm done. And I can get one more thing to intersect it. The perpendicular bisector of this segment will intersect that segment at the desired center, because I want a circle that passes through a point and its inverse. That will make this circle a hyperbolic line. Well, we are in luck because I have the center and I have a chord. The chord theorem says, or the sword theorem says, if I do the perpendicular, so I set up my T-square through that point, see, my T-square is lying along this chord, and it goes through here. So here's the perpendicular bisector. I have to extend it, of course, because it's got to cut through there. Now there's the perpendicular bisector of, if I want to label this point A, that's A inverse right there. And this guy here is the perpendicular bisector of AA inverse. So any time I put the point of my compass on this perpendicular bisector and put the pencil at A, it will pass through A inverse, making the circle a hyperbolic line. Well, check it out. Hyperbolic line centers are on here. Perpendicular lines to the given line are on here. So this point of intersection stands for the perfect spot where I will have a hyperbolic line and it will be perpendicular to the first hyperbolic line. Let's see if it looks right. The math says it's going to be right. Let's see if it actually looks correct, because looks don't decide the matter, but they also are a selling point. I should have an arc of a circle that is meeting circle O at a right angle. That looks pretty good. And it should be meeting this other hyperbolic line at point A at a right angle. That looks really good. Looks don't matter. It's the math. See? The center of this circle is on the perpendicular bisector of AA inverse. Here, let me just show you. This line that I just made, it's going to pass through A inverse. I guarantee you. Watch. It's going to catch A inverse. There it is. It caught A inverse. So it goes through a point in its inverse. So it's a hyperbolic line. Yeah, I missed by a millimeter. Sue me. And anyway, I've got the math is supporting the claim that we have a right angle right there. So if we did right, one of the things that should happen is if I do the radical axis for this new hyperbolic line, it should lead right to that center because these lines are perpendicular to each other. Let's see if that's the case. I've got a little pencil here and a ruler, and I'm going to draw through there, and boom, look at that. This radical axis catches that center. So I have really good evidence that these two circles, the mathematical evidence is all there, these two circles are perpendicular to each other, and since they both go through a point in its inverse, they're both hyperbolic lines. Actually, I built this one to be a hyperbolic line. Then I got the point in its inverse, which makes this second thing a hyperbolic line. Now I could keep going around this circle, choosing another point, making another perpendicular, another point, another perpendicular. Doing this kind of move works until it's time to close it up. Can you imagine? We've worked our way around. You know, we've got some stuff that's going along like this, you know, and we get over here somewhere, and we'd like to get a hyperbolic line that is perpendicular to this one and this one. Oh, well, that's ultra parallels. You would have their radical axes meet. That's your desired center. Do the auxiliary circle that's in the book, and you would close this off with the perfect hyperbolic line that's perpendicular to both. So this move, being able to make a perpendicular to a line at a point, a very nice thing. There's going to be further wiki questions using this idea. So there you go, 7 minutes, and if you want to replay this a few times, go ahead. Be my